So welcome everybody to this latest revision video for the GCSE AQA Maths exam of 2022, and in this video we'll be going over the algebra section of the revision list for paper 1 using some past exam questions related to those topics. And just a reminder that there is a copy of the questions in the description below for you to download and have an attempt at before watching this video and going through the answers. Now, before we get started working through some past questions based on this sort of revision list, let's just have a quick breakdown of what actually these could actually mean, because obviously the questions that are involving in this video might not cover explicitly everything that's in these topics. So it's definitely worth investigating these questions and these topics a little bit more in detail. So starting with equations of a straight line, so this is going to be relating to y equals mx plus c. So again, you could get a graph. You could have to plot a graph. You may have to work out with parallel and perpendicular. You may have to look at function like a formula rather than it be y equals mx plus c. It might be related to something else. In terms of a linear equation, that again refers to just working with single x's. So you're looking at straight line graphs, maybe looking at x equals y equals intercepts, maybe linking to simultaneous equations. Then with simplification of algebraic fractions, it is exactly what it says on the tin. So you could end up with something more expansive. So for example, you could get x over, let's say, x plus 3 minus 2x plus 1 over 4, let's say, and you want to write that as a single fraction. You may get something simple like x over 5 minus x over 10, and it might be a multiple choice question. So again, something along those lines where you're using the knowledge of fractions to combine multiple fractions into a single one. Simplification, that's basically collecting like terms. So it could be a case of expanding brackets, could just simply have an expression and you just need to collect the like terms. So could be something like that. Then when it comes to factorizing quadratics, you could end up with something sort of basic, or you could end up with a more complicated factorization of a quadratic. You're also looking at difference of two squares, or you're looking at completing the square. So it's worth mentioning those. Changing the subject, again, it could be very basic. It could be more complicated where you've got two of the letters and you then need to factorize it. Then we're moving on to graphs, recognizing graph shapes. So again, recognizing what straight line graph, quadratic, cubic, reciprocal, what's the other one? Exponential graphs. So just recognizing what the shapes are. Now, sketching functions, this is more of a new topic, and as a teacher, I have my own interpretation of what sketching functions are, and I'll be honest, I've never seen this in previous GCSE papers, and I'd say that this generally, what you might have to find is find this topic in a textbook, or look at level 2 further maths for sketching functions in terms of this. Again, I could be absolutely going off on a tangent in the fact that, excuse the pun on that one, in terms of sketching function, it might just be just sketching a graph, a linear graph, quadratic graph, or a function onto by drawing a table of values, etc. Speed time, again, quite scarce, these questions looking at past papers, but again does seem to be more and more popular. So speed time graph looks at interpreting, answering questions, looking at distance, looking at the area under a graph and how you would work that out. So again, I would say unlikely to appear in past papers, so I would definitely research this on other websites and textbooks where you'll find more questions related to that topic. Inequality region is about sketching graphs. So again, you want to be able to write inequalities from a graph, but also interpret inequalities and put them in a graph by shading the correct region, knowing when to use a dashed line, when to use a solid line, etc. Also maybe potentially looking at quadratic inequalities as well. Then interpreting graphs, again, it's just a case of recognizing what the gradient means, so it's a rate of increase or the rate of decrease, understanding what the y-intercept means, so that's usually when the x value is 0 or the initial starting value, something along those lines. And then when it comes to sequences, again, remember that there's a couple of sequences that you need to look at. So there's an arithmetic sequence, you can have a geometric sequence, you can have a linear sequence, you can have a quadratic sequence, but the fact that it says algebraic sequence basically could also mean that rather than using numbers in a sequence, you may be using letters. And again, these types of questions have been coming up more and more in past papers where they're replacing numbers with letters and you still need to follow the same. So it could be a case of also looking at Fibonacci sequence as well, using letters rather than numbers. So let's get started on some questions. So again, a reminder that you can download these questions in the description below by clicking on the link, and obviously I recommend doing that before watching this video as we go through the answers. So if we're looking at question 1, which relates to equations of a line, it says that the line M has the equation of 3x plus 2y equals 7. Circle the gradient of the line M. So for this, what we need to do first is make y the subject. So for this, we've got 2y equals, so if we take the 3x over to the side, we have 7 minus 3x. Then we divide everything by 2, so we get 7 over 2 minus 3 over 2x, and the gradient is the coefficient of x, so it's this number here including the sign, so it's the second option. And with question B, it says line N has the equation of y equals 5 minus 3 over 4x. Circle the gradient of the line that is perpendicular to the line N. So here we can see that the gradient is 3/4. Now for perpendicular, what we need to do is do the negative reciprocal. So we need to do the negative reciprocal of 3/4. So in this, or minus 3/4 I should say. So then all we then need to do is basically flip the fraction and change the sign. So here we're going to have 4 over 3 and it's positive, which is our third option. Then moving on to question 2, it's again sticking with the equations of a line. So it says y equals 5x minus 4 is the equation of a straight line. Write down the gradient of the line y equals 5x minus 4. And so it's going to be the coefficient of x, so the gradient here is 5. Then for B, it says write down the coordinates of the y-intercept of the line. Now the y-intercept is at minus 4. Now to find the y-intercept, all you need to do is make x equal 0. So when x equals 0, I end up with y equals, and it's going to be 5 times 0 minus 4. So y equals minus 4. And this is my coordinate. So x equals 0 and minus 4. Then moving on to question 3, it says the graph shows the line of y equals ax plus b. Work out the values of a and b. So here a equals the gradient and b equals the y-intercept. So I can see straight away that my y is going to be 100. Well, y-intercept is 100, so b equals 100. And so the next thing I then need to do is find the gradient. Now to find the gradient, all I need to do is just be wary of the units going across on the x-axis and the units going up on the y-axis. They are different, so it's not just as simple as counting the squares. Now what I recommend that you do is pick, now the bigger the triangle, the better the easier I would say it is going to be to calculate the gradient. So if you pick 2 coordinates, so I'm going to pick this coordinate here because it's a nice coordinate. So it's 0, 100. And I'm going to pick another coordinate. Let's go for 40. And if I just go up to 40, I get that this coordinate here is 40 and it's roughly at 340. So now to work out the gradient, I'm going to use the formula of y2 minus y1 over x2 minus x1, where the values are going to be, so this is my y2, this is my x2, this value here is my x1, and this value here is my y1. So then you substitute the numbers in, what do I get? Well, I'm going to get 340 minus 100 over 40 minus 0. So I've got 240 divided by 40, which gives me an answer of 6. So A equals 6. So then writing down the equation, it's going to be y equals 6x plus 100. But the question is asking me to write down the values of A and B. So A equals 6 and B equals 100. Then for B, it says work out the value of y when x equals 80. So all I'm going to do is I'm going to use this formula here. So substitute x equals 80. So I've got y equals 6 times 80 plus 100. So I've got 480 plus 100. Give me an answer of 580. Then for question 4, it says here is an identity. To use the identity to work out the value of 193 squared minus 7 squared. And you must show you're working out. So I need to use this. So here, what I've got is I've got x equals 193 and y equals 7. So all I'm doing is I'm comparing this to this. So if I substitute these numbers into this algebraic expression, then what I end up with is 193 plus 7. And 193 minus 7. Now this equals 200 and this equals 186. So what I then want to do is multiply 186 by 200. Now 186 times 100 is going to be 18,600 rather. So if I just double that, what do I get? Well, I get 37,200. So then moving on to question B. So this represents a difference of two squares, which are called dots, or more commonly known as dots. I can't say I take credit for inventing that. So setting up my double brackets, what do I have to square to get 100a squared? Well, I need 10a. What do I need to square to get 81b? Well, that's going to be 9b. One's a plus, one's a minus. It doesn't matter which one's a plus or which one's a minus. Then moving on to question 5. So again, another identity. Now this is where we need to compare the coefficients. So let me just write that. So comparing the coefficients. So first things first, let's expand the brackets of this left hand side. So if I do that, I get 3ax squared. Now when I'm expanding the brackets, what I'm trying to do is keep the x's at the end. So here I'm not going to write 3x squared a, I'm going to write 3ax because a and b and c are all numbers as well, just to know what they are. So then expanding that further, I get plus 3bx and then minus ax minus b, and that is algebraically equivalent to 12x squared minus 19x plus c. So then comparing the coefficients of x squared, what I've got is I've got 3a on this side and I've got 12 on this side. So what I've then got is I've got 3a equals 12. So that means then a equals 4. So there's my first value. Then comparing the coefficients of x, then what I've got is I've got 3b minus a on the left hand side. So I've got 3b minus a on the left hand side. And how many x's have I got on the right hand side? Well, I've got minus 19. So then I already know the value of a, so 3b minus 4 equals minus 19. So 3b equals minus 15. So then b equals minus 5. Then comparing the constant, so in other words, just the number at the end, so comparing the constants, I can spell it. Then what I've got is I've got minus b equals positive c. So minus b equals c. Now if b is minus 5, so I've got minus 5 equals c. Two minuses become a plus, so c equals positive 5, and there I've answered my question. Then moving on to question 6, it says expand and simplify. So all we need to do here is expand the brackets. Now, which two brackets you expand first is entirely up to you. But one thing I do notice is that these first two brackets is a difference of two squares. So here what we've got is, that's going to be 4x squared minus 25. Then I've still got to expand that with 3x plus 7. So that's exactly what I'm going to do now. So then from that, what I've got is 4x squared times 3x, which is 12x squared, plus 28x squared, and actually that should be a cubed, 28x squared, and then minus 75x, and then minus 175. And then all I've got to do is just quickly check, can I simplify any of those? So again, collecting the x cubes, x squared, x is all the constants. No, I can't. So that there is my final answer. So it's 12x cubed plus 28x squared minus 75x minus 175. Then moving on to question 7, it could then looks at factorising this, I would say, a complex quadratic. Now again, you can do this by inspection. You can just know what it is in terms of setting up your brackets, especially as your coefficient of x squared is a prime number. However, what I'm going to do is I'm going to kind of show you how to solve this properly, or not properly, but algebraically. So here, what I'm going to do is find the magic number by doing the coefficient of A times the coefficient of C. So 3 times minus 10 is minus 30. I then need to think of two numbers that multiply together to give you minus 30, but added together give me minus 13. And that's going to be minus 15 and positive 2. So what I'm going to do is I'm going to swap minus 13 for those two numbers. So I've got 3x squared minus 15x plus 2x minus 10. Then from this, I factorise the pairs. Now, if you have absolutely no idea what I'm doing, do not worry. There's a video on my channel that goes over this. I've got 3x, and then it's going to be x minus 5 plus 2x minus 5. So one of the brackets is x minus 5, and the other bracket is using these multiples. So I've got 3x plus 2, and there I factorised it. Then with b, it then says simplify. We've got this expression. Now, one thing you should be able to note is that this is part A. So the only thing I need to factorise is 3x squared minus 15x. Now, you may think this is another quadratic, but it's not. So it's just a single bracket. So I take 3x and I've ended up with x minus 5. And then 3x squared minus 13x minus 10 is 3x plus 2 x minus 5. So what I've then got is that this equals 3x x minus 5 over 3x plus 2 x minus 5, and then the x minus 5's cancel, leaving me with my final answer of 3x over 3x plus 2, and that can't be simplified, so that there is my final answer. Moving on to question 8. So again, looking at algebraic fractions. So it says show that 7 plus, and it is a plus, let me just make that a little bit more obvious on screen, plus 10 over x plus 2 equals x over 9 over x. So what we want to do here is get a common denominator. Now, common denominator is going to be, in this case, x plus 2. So this middle fraction is absolutely fine. So then 7 times x plus 2 over x plus 2 is going to equal 7x plus 2 over x plus 2. So then looking at this, what I end up with is 7x plus 2 over x plus 2 plus 10 over x plus 2. Which then I can then, as the denominators are the same, I can then link up the numerators. So I've got 7x plus 14 plus 10 over x plus 2, which then gives me 7x plus 24 over x plus 2. And that all equals 9 over x. Now from this, what you then want to do is cross multiply. So if I cross multiply, what do I end up with? Well, I end up with 7x plus 24 equals 9 lots of x plus 2. Then expanding the left hand side, we get 7x squared plus 24x equals 9x plus 18. Then I take all of this over to this side, and I end up with 7x squared plus 15x minus 18 equals 0, which is what they wanted me to show. Then moving on to question 9, it says circle the expression that is equivalent to 2x squared plus 1 over x, where x is not equal to 0. Now, this not equal to 0 is only to make sure that it's a valid algebraic fraction, because obviously you can't divide by 0, so therefore they need to specify that x can't equal 0. So here what you do is you split the fraction up, as we've only got a single denominator, so I can have that over x and that over x. This cancels out, so that cancels with that x. So what that then becomes is 2x plus 1 over x, which is our third option. Then moving on to question 10, it says simplify 4x squared minus 1 over 4x squared plus 12x plus 5. So again, what we need to do is recognize that the top line is a difference of 2 squares. So that's then going to become 2x, 2x, and then we've got 1 and a 1, 1's a plus, 1's a minus. Now the bottom, again, we just need to factorize this. So if we factorize this, and again I'm going to use the same method, so 4 times 5 is 20. So I need to think of two numbers that multiply to give me 20, added together to give me positive 12. So my two numbers of choice are going to be 10 and 2. So I swap the 12x for 10 and 2. So I've got 4x squared plus, let's go for 2x, plus 10x plus 5. Then if I factorize these two things, I end up with 2x, and I've got 2x plus 1. And then I factorize these two things, in which I've got 5, in which I've got 2x plus 1. And then that then gives me 2x plus 5 and 2x plus 1. So then what this fraction then becomes is then this becomes 2x plus 1, 2x minus 1, all over 2x plus 5 and 2x plus 1. And as you can see, I've got a common bracket, so this cancels with this, leaving me with just 2x minus 1 at the top and 2x plus 5 at the bottom. Then moving on to question 11. So again, algebraic fractions. So we're simplifying this. Now here, our common denominator is going to be x minus, well, it's actually going to be x minus 2 as our common denom. So I multiply this fraction by x, and I'm going to multiply this fraction by x minus 2. So what do we get? Well, we're going to end up with 4x over x minus 2 minus, and I'm going to end up with 3x minus 2 over x minus 2 with an x in front. So as the denominators are the same, I can join the numerators up. So I've got 4x minus 3x. Now just be careful, because I've got this minus here, minus and a minus, that's going to become minus 6, but then it's going to become plus 6 over x minus 2. That then becomes x plus 6 over x minus 2. And that doesn't factorize, and I can't cancel anything out. So then that then becomes x plus 6 over x squared minus 2x, or you could even leave your answer like that. So any of those two would be absolutely fine as your final answer. Now looking at question 12, it says simplify fully. So again, looks very, very similar to what we've done previously. So if we factorize the top, we notice that a common factor is 4x, so 4x, and I've got 1 minus 2x. And then if I factorize the bottom, I get a common factor of 6, so I've got 6, and then it's 2x minus 1. Now one thing you notice here is that we've got in our brackets, our terms are the wrong way around, so we can't actually cancel them down, because in the top one our 2x is negative, in our bottom one our 2x is positive, and our minus ones are also different signs as well. Now obviously we can't leave our answer like this, because all we've done here is factorize, we're not simplified fully. So this is where a bit of algebraic manipulation comes into play. Now what I'm going to do here is basically, so to change the signs in the bracket, what you need to do is change the sign of the multiple. So in other words, the number outside the bracket. Is what we need to do. So either we're gonna, either we're gonna have minus 4x, and then I flip the numbers in that first bracket over, but I keep the bottom one the same. Now, by doing this, if I expand the top, I'm still going to end up with minus 8x squared minus positive 4x. So I'm not actually changing anything. This is what we mean by algebraic manipulation. Or what I can do is change the sign of the 6 and flip the terms in that bottom bracket. So I end up with 4x, 1 minus 2x over minus 6, and it's going to be 1 minus 2x. Now either or, whichever I've got, so if I did the first example, my 2x plus 1s cancel, leaving me with just minus 4x over 6. Now if I do the same with the second one, again the 1 minus 2x cancels out, but I'm still left with minus 4x over 6. And again, 4x over minus 6 is still the same. So that there I've simplified. And obviously then we can simplify this further by having it as minus 2x over 3. And so that would be actually be our correct answer, not this one. And well, actually I shouldn't have missed that out. So let's just keep that in. I just shouldn't have underlined it. And that then becomes minus 2x over 3. So moving on to question 13, it says expand and simplify. So again, we just need to expand the double bracket. So we get 6x squared minus 8x plus 3x minus 4. And then simplifying that, we get 6x squared minus 5x minus 4. And then with b, again, we factorize. So I think of two numbers that multiplied, well, you give me minus 24 as my magic number. So two numbers that multiply together give me minus 24, added together give me minus 23. So I've got 6x squared minus 24x plus 1x minus 4. So then factorizing this, I get 6x, and then I've got 1 minus 4x. And, oh no, I haven't. I've got x minus 4, and then factorizing this, I've got a common factor of 1, so that's going to be x minus 4. So looking at this, I've got 6x plus 1 and x minus 4. So that there is what I need to write. We've done. So moving on to question 14, I've just got to factorize this quadratic expression. So again, think of two numbers that multiply together to give me minus 6. And added together give me minus 1. So my two numbers are going to be 3x, 3 and 2. So I've got minus 3 and positive 2. So then looking at which numbers pair up nicely, so I've got 2x squared plus 2x minus 3x minus 3. Factorizing these two things, I get 2x, and I've got x plus 1. And factorizing these two things, I've got 1 and then, 3. And I've got x, well, should be a minus there, and x plus 3. So then I've got 2x minus 3, and what have I done there? Let me just correct that to a 1, like so, and then I've got x plus 1. Then it says hence simplify. Well, I've already factorized the top, so the bottom one again is a difference of two squares. So I've got x minus 3, x plus 1 at the top, and at the bottom I've got, what do I have to square to get 4x squared? Well, that'd be 2x. And what do I have to square to get 9? That's going to be 3. One's a plus, one's a minus. And again, notice that I've got 2x minus 3 at the top and the bottom. So I've got x plus 1 over 2x plus 3. Moving over to question 15. So now moving on to rearranging the formula. So here I want to make x a subject. Now one thing we notice is that I've got two x's. So what I need to do is put brackets around this denominator and take that to the top by to the left hand side to make that all one single line. So here I've got y, x plus 1 equals 3x minus 2. So you always want to get rid of the fraction part. Then if I multiply out the left hand side, I get xy plus 1 equals 3x minus 2. And then what I then want to do is get all the x's on one side and everything else onto the other. So I end up with xy minus 3x equals minus 2 minus 1, which is minus 3. Then, now I can't simplify this, but one thing I can do is factorize it. So I end up with this, and you can see there that what I've then got is now just one single x. So I can then take the y minus 3 over to the other side. So I've got x equals minus 3 over y minus 3, and that there is my final answer. So x equals minus 3 over y minus 3, and there we can move on to the next question. Next question then says rearrange 2a plus c equals 5a minus b, making c the subject. So for this, again, we don't need to expand the brackets because I've only got one single c. So one thing I could do is take the 2 over. So what I've got to end up with is a plus c equals 5a minus b over 2, and then I've just got to get rid of the a. So here I've got c equals 5a minus b over 2 minus a, and there I've answered the question. So I could leave my answer like that, or if you did expand the brackets, we get 2a plus 2c equals 5a minus 5b. I then take this 2a over to the side, so I end up with 2c equals, and it's going to end up with 3a minus 5b. I then take the 2 over to the side, so I've got c equals 3a minus 5b all over 2. Now if I expand the brackets, I'd end up with the exact same thing. The only difference is that in terms of this a, that's where I'd end up having to do a common multiplier, a common denominator, and I'd still end up with the same answers. So either writing your answer like this or writing your answer like that, although they look very different, they are the same thing and should get you the full 3 marks. Question 17 looks at sketching graphs. Now for this, it's just a case of recognizing what the graphs look like, but if you ever struggle to sketch a graph, to understand what it looks like, then just simply draw a table of values. So here we've got negative, positive, so if you just substituted x equals -2, -1, 0, 1, 2, and then worked out the y values by substituting the x numbers into the equation, you would have a set of coordinates and then just do a little sketch. But generally speaking, what you should find is that this graph looks like that. So it's a bit of like an S shape. It's basically a curve that starts up positive in the positive quadrant and then moves to negative in that third quadrant. The next question then says sketch the graph of x squared plus 3. So here all we then need to do is recognize that this is a quadratic graph and we're plussing 3. So again, if you did a table of values, well basically it's the graph of x squared moved up 3 places. So if we imagine that 3 is here, we're then drawing a cubic graph. Doesn't matter about the thickness, as long as it intercepts at 3, then that's fine. And I would certainly recommend that you do label that point there 3, doesn't matter whereabouts it is. Then for C, we just need to then sketch the graph of y equals 1 over x. So this is an exponential graph, or reciprocal graph I should say. So what this therefore looks like is this here and this here. So basically the graph does not touch the y-axis and looks something along those lines. Now question 18 says here is a velocity time graph for the car for 50 seconds. And it says work out the average acceleration during 50 seconds. Give your units as of your answer. So for this, what we need to do is basically work out the gradient of this point here. So what we then need to do is basically it's going up from 30 to 50. So I do 30 divided by 50. And so all we're doing is working out the gradient of that line. So if I just draw a line from where it starts to where it ends, what I need to do is work out the gradient of this line. So it's going to be 30 divided by 50, which gives me 0.6. And then the units are going to be meters per second squared, or meters per second squared, or you could write your answer as 0.6 ms to the power of -2. So any of those two answers would be absolutely fine. The next question then says estimate the time during the 50 seconds where the instantaneous acceleration equals the average acceleration. You must show you're working on the graph. Now for this, what we need to do is, if I just draw a more accurate gradient of the line, and let me just get rid of that, and using a ruler, which is basically what I should have done first, so let's just change the color as well, and draw a point from where it starts to where it finishes, like so. Now what I'm looking for is where the gradient of the tangent is the same as that blue line. So I'm looking for where on the curve is the gradient of the tangent, if I would draw a tangent on the curve, going to be parallel to that blue line. And I would say that where it's parallel is somewhere roughly around there. So I would say in terms of your answer, and it's important that you do draw that purple line, which are a tangent, I would say any answer between 11 and 14. So any answer between 11 to 14 would be fine. Then moving on to question 19, which then moves on to inequalities. It says points in the shaded region satisfy the three inequalities, and what we need to do is use the inequality to describe the shaded area. Now for this, what we need to do is first of all write down the equations of each of those three lines. So this line here is going to be x plus y equals 7. Now these types of lines are very, very common. If you notice that the y ordinate and the x ordinate where it intercepts are the same, then the equation will be x plus y equals then whatever those two numbers are. This number here, this equation of this vertical line is x equals 2, and this line here represents y equals 1. Now the next thing I've then got to do is decide what the directions of the inequalities are going to be. So I've got x plus y and I've got 7. Now because it's below, it's always less than, and it's a dashed line, so it's no equal sign there. For x equals 2, again I'm looking for the right hand side, so this shaded area is on the right, and again it's a solid line, so it's going to be equal to. And then finally I've got y and 1. Now the shaded area is above the line, so again it's going to be that, and it's dotted, so there's no line underneath, so there is my final three inequalities. Then moving on to question 20, it says on the grid draw lines to show the region satisfied by these three inequalities. So if I just zoom out a little bit, hopefully we can fit it all in. So this basically, it's important that you know how to plot these lines. So I need to plot what x equals 4, which is a vertical line through 4. This is going to, I need to plot y equals x, which is a diagonal line, and so is this one. So I need to plot x plus y equals 4, and then it's just a case of knowing which side and which lines it's going to be. Now all of them are solid lines because there is a line underneath each of the inequalities. So let's take this up in single measures. So here x is less than 4 with a solid line, and so what I then need to do is at x equals 4, I'm just going to draw my line like so. Then what I then need to do is y equals x. So again I'm going to use a solid line for this, and y equals x basically goes through the coordinates of 1 1 2 2 3 3 4 4 and the origin. So it's just a case of drawing a line that looks like that. And the final line, as we mentioned, is x plus y equals 4. So I'm looking for this point here. Let me change the color. So I'm looking at this point and this point. So I'm drawing a straight line through those 2 points. And again, if the equation was a little bit more complicated, I'll do a table of values. So I'm looking for the region. Now this is where I then need to look at this. So looking at the blue line, I want the area to the left. So that's this area here. For y equals x, I want it where it's above the line. So notice that it's y is less than x. So here I'm looking for this region here where it's below the line, sorry. And then for the other line, the red line, I'm looking for it's above. So I'm looking for this region here. Now, generally speaking, you should be able to kind of use your common sense to recognize that it's this region that we want. And so that's the area that we then need to shade or label with R, which is what I'm going to do here. Then moving on to question 21, we then move on to sequences, and it says these patterns are made using sticks. The number of sticks in each pattern form a sequence. Show that in the first 5 patterns, the first 5 patterns use a total of 65 sticks. So remember that this is not asking you to draw the 5th pattern. It's not a case of showing that the 5th pattern uses 65. What I need to do is add up and work out what the number of sticks is going to be. So here for pattern and number, and we've got the number of sticks. And again, this is just one way of doing it. So I've got pattern 1, 2, 3. So for pattern 1, I'm using 5 sticks. For pattern 2, I'm using 1, 2, 3, 4, 5, 6, 7, 8. For pattern 3, I'm using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can see that the patterns are going up by 3. So pattern 4 is going to have, it's going up by 3 rather. So pattern 4 is going to have 14 and pattern 5 is going to have 17. So then if I then add up those numbers, so I've got 5 plus 8 plus 11 plus 14 plus 17, it all adds up to 65. The next question then says work out the nth term of the sequence. So the numbers in the sequence are 5, 8, 11, 14 and 17. So here what we've then got is, well, the difference is plus 3. So I'm going to have 3n and then it's plus 2 because I've got, so the difference is plus 3. So I've got 3n. How do you get from 3 to 5? Well, I need to add 2 and that all equals s. Moving on to question 22, it says the nth term of a sequence is 5n minus 2. Work out the third term. So all I've got to do is just substitute n equals 3. So 5 times 3, which is 15, take away 2 is 13. Then moving on to question 23, it says which of these is a geometric progression? So a geometric progression is where the difference between the terms is going up by a multiple of a number. So you're multiplying the previous term by a number to get the next term. And that's just a case of recognizing the difference. So here I've got 2 to 4 to 6, that's adding. So that's definitely not the one. The next one I've got a difference of 1, then it's difference of 2, then it's a difference of 3, then it's a difference of 4, so no, that's not going to work. The next one I've got, well, one way of doing it is basically taking two consecutive numbers, dividing them. So I've got 6 over 2 and 18 over 6, and see if they give you the same number. So that's going to give me a 3, that's going to give me a 3. So that there looks like a possible answer. And again, just to prove this, I've got 6 over 2, which is 3, but 10 over 6 is going to give me 1 point, so it's 5 over 3, which is 1.6 recurring. So they're different, so the correct answer is our third option, which has been highlighted there. Question 24, it says work out the nth term of this sequence. So again, the difference is going up by plus 4, so it's a linear sequence. So I've got 4n. What do you have to do to get to 4 to get to 6? You need to add 2. Then for question 25, it says the nth term of a sequence is 45 minus 4n. Work out the first 3 terms. So for the first term, n equals 1. So I've got, oh, don't know what's happened there. We've got 45 minus 4 times 1. 4 times 1 is 4, so we've got 41. So that's the first term. The second term is when n equals 2. So I've got 45 minus 4 times 2, which is 8. And that's going to give me an answer of 37. And then all I'm doing is taking away 4, so then that then becomes 33. It then says work out the value of the first negative term of the sequence. So again, one way of doing this is looking at 45 minus 4n is less, well, let's say is less than 0. So then we just solve this. So 45 is less than 4n. Divide 45 by 4 gives me n. So dividing by 2 gives me 22.5. Dividing that by 2 gives me 11.25. So I'm looking between the 12th and the 11th term. Now, when n is 11, I end up with 45 minus 44, which is 0, which is 1. But then with the 12th term, I've got 45 minus 4 times 12, which is 48. And that gives me minus 3. So the first work out the first negative value in the sequence is going to be minus 3. Then moving on to question 26, it says the first 3 terms of the sequence and the nth term are, and it says here, it says clearly, explain clearly why the n plus 1 term of the sequence is n plus 1 over n plus 2. So if the nth term is n over n plus 1, then the n plus 1th term is where we substitute n with n plus 1. So rather than using n, I swap that with n plus 1. Then that, if I just write term there, so what that then becomes is n plus 1 and then over n plus 1 plus 1. And if I neaten that bottom, the denominator, I get n plus 2, which is what they wanted me to show. It then says show that the difference between the n plus 1th term and the nth term is this. So from this, what I've then got is to work out, well, the n plus 1 term is n plus 1 over n plus 2. And I'm going to subtract that from n plus 1. So this then becomes an algebraic fraction that we then need to write as a single fraction. So here I multiply this first fraction by n plus 1 over n plus 1. And I multiply this second fraction by n plus 2 over n plus 2. Now if I do that, what I end up with is my first numerator is going to be n plus 1 n plus 1 over n plus 1 n plus 2, and then minus n minus 2 over n plus 1 n plus 2. Then now the denominators are the same, I can then join up the numerators. So I've got n plus 1 squared minus, and then it's going to be n squared minus 2 n. And then from this, what I can then do is, let me just get rid of some of this. And I'm not going to expand the bottom. Now if I expand the top, this first bracket, I end up with n squared minus 2 plus 2n plus 1 minus n squared plus minus 2n. And actually that should be a plus there. And then from this, we can then notice that things start to cancel out. So this cancels with this, and this cancels with this, leaving me with just 1 over n plus 1 n plus 2, and there is my final answer. Then for question C, it says two terms of the sequence have a difference of 1 over 110. It says what are the two terms? Well, what we're looking for here, if we relate it to that, this is the formula for the difference. So I've got 1 over n plus 1 n plus 2 equals 1 over 110. So what I'm looking for is two consecutive numbers that multiply together to give you 110. Well, that is basically going to be 10 times 11. So one fraction is going to be over 10, another one is going to be over 11, and then using the formula of n over, and if I go back to the nth term formula, it's n plus 1. So then if n plus 1 is 10, then n is going to be 1 minus that, which is 9, and if n plus 1 is 11, take away 1 gives me 10. So then there are your two terms. And that concludes the end of this algebra section of this paper for paper 1. Now if you have completed the paper but you didn't quite get the answers but you want to know the individual marks, then I have included the mark scheme in the attached document so you can see and mark how many marks of a part question you have received. And again, no grades are available because these are just a mixture of certain topic questions.